let's go back and take a look at converting the other direction now. And I'm going to need a little bit of room here, so I'm going to write up here, let's give the equation 9x squared plus y squared equals 9. And if you did a little solving on that, you'd realize that that's kind of an ellipse. And we also know that our cosine, our sine are your x and y. So if I do a little bit of substitution here, I get our cosine theta quantity squared plus our sine theta quantity squared equals 9. And if I rewrite that as 9r squared cosine squared theta plus r squared sine squared theta equals 9. Factor out that r squared because that's, when you're typing it in the equation, that's how you're going to make it look, is r by itself. Plus sine squared theta equals 9. So I get r squared equals 9 divided by 9 cosine squared plus sine squared. And if you're looking for, an r, you'd have to square root both sides if you wanted to get, and make sure you do the plus or minus when you type that in if you wanted to look at the equation. Just for the fun of it, I thought, just like the top section, I did 2 examples. I was thinking maybe I'd do 2 examples here. And a simple equation like this, we know this is a hyperbola looking thing. If I do the substitution, we already know the substitution for x and y, so I'm going to put r cosine theta times r sine theta equals 1. And putting the r's together, I get a cosine times sine. And if I get the r by itself, I get 1 divided by 2 cosine sine. And again, if you wanted it to be r equals, you'd square root both sides. So there's kind of the converting both directions. Let's take a look at this one. Well, we know that this is a cosine sum formula. So let's go to our formula sheet and use the sum formula. I'm going to leave the r out front, and then I'm going to use the cosine sum formula. So it's going to go cosine theta cosine 2 pi over 3 minus sine theta sine 2 pi over 3. And that's still equal to 4. And if I do a little bit of simplifying here, I get r times the quantity. The cosine at 2 pi over 3 is negative 1/2. The sine at 2 pi over 3 is square root of 3 over 2. And then I'm going to convert. First thing I'm going to do is distribute that r, because that'll give me an r cosine and an r sine. So I'm going to say negative 1/2 r cosine x minus square root of 3 over 2 r sine theta equals 4. And I know that r cosine is the same as x. R sine is y. And if I recall correctly on something like this, this is something that on the test they asked you to put it in. If you kind of look at it, it's a linear equation with yucky slope and yucky y-intercept, but nonetheless it is a linear equation. And I think they had you do one of those on the test last year. Might want to pause it. I'm going to erase to get the next equation. Alright. Just for the fun of it, I want to do a similar one to that. I want to do what happens if I have 4 equals r cosine of that? And that would be a cosine difference formula, so I'm going to put r in front, and I'm going to say that's cosine plus, because the cosine's opposite, sine, and then simplifying, I might just simplify this one down. I didn't simplify the other one, but I think I'll do this one. The cosine at pi over 6 is half, so I'm going to rewrite cosine as the x. Oh, nope, that's not true. So I'm going to rewrite that as, and I'm going to try to distribute at the same time. So square root of 3 over 2 r cosine, and plus the sine is the y, gives me a half. So I'm going to say half of r sine. And I know that r cosine is equal to x, r sine is equal to y. And just for the fun of it, I'm going to rewrite it as 1/2 y equals negative root 3 over 2x plus 4 times 2 So, something like that, very possibly on your test. Let me pause it if you need to. I'm going to make room for this one. And on this one, we're going to convert the given equation to polar, so doing more of that. I know that x is r cosine, and y, did I just not do these? Yeah, I think I just did that one before. All right. Just for the fun of it, let's talk distance formula in polar coordinates. We have 2 points in polar coordinates. And if you recall not too long ago, this might look a little bit like the law of cosines. Something to think about. Might want to write that one down. So if it passes through the origin, your angle is theta sub 0. So let's just make up a couple points here and find the distance. So if I pick one point out here to be 6 pi over 3 and one over here to be 2 pi over 6. So I'm going to plug in and use that. So let's go with the distance squared is equal to your R1, which is, I think I drew the 6 first, plus R2 squared minus 2 times 6 times 2 times the cosine of the difference of the angles. Now notice that I use the bigger one to be the first point, so my angle is positive. And so then I get 36 plus 4 minus 24, and the cosine at pi over 3 minus pi over 6 is pi over 6. The cosine is the x value, which gives me root 3 over 2. And I get 40 minus 12 root 3 is my distance. Give or take a little bit. All right, so that's a distance formula. Just for the fun of it, I'm going to plug that sucker into my calculator. I'm going to pause. And so when I plugged it in, I got 19.2 for the 40 minus 12 root 3. And then when you square root both sides, the distance from here to here is 4.38, which seems like a pretty good idea for an answer. All right, let's take a look at this one down here. The equation of a line polar form is given by that. And specify the perpendicular distance from the origin to the line. And let's get started on that. Excuse me. So I think where I left this one, because we did this example, let's go back. I think we did that one over here. And I think this is where I left the answer at. So I'm going to solve that for a y equals, just for the fun of it. And I'm going to have negative root 3 over 2y equals 1/2 x plus 4. And then I'm going to multiply the entire world by 2 over the square root of 3 negative. And I'm going to get negative 1 over the square root of 3x and minus 8 over the square root of 3. And I'm going to leave it like that for now, because in this first question A, it says the perpendicular distance from the origin. So if I want to use perpendicular to this, I know that the slope of this one is that, and the perpendicular slope is going to be the opposite reciprocal, which gives me the square root of 3. Instead of negative 1 over the square root of 3, it's just the square root of 3. So that's going to be my perpendicular slope. And if it's going to go from the origin, it's going to go through the point 0, 0. So the equation of the line that is perpendicular to our root and goes through the origin is going to be y minus y1 equals m times the quantity x minus x1, which is 0. And so I get y equals the square root of 3x is the equation of the perpendicular line that goes through the origin. All right. So if I use some values here to actually plug in to those values, if I plug in 0 in for theta, I get r times the cosine of 0 plus 2 pi over 3. And we know the cosine at 2 pi over 3 is negative half. And so I have r times negative half equals 4, so my r is negative 8. And if I put in pi over 2 for my theta, I'm going to have r cosine of pi over 2 plus 2 pi over 3 equals 4. Well, pi over 2 plus 2 pi over 3, if I plug that in, I'm going to get, oh dear, going to have to do some math. I'm going to pause. And when I put in the square, I got r cosine of pi over 2 plus 2 pi over 3. And that's the cosine sum formula, which I plugged in, and I'm not going to show you all of it. But I get r times the quantity of negative root 3 over 2 equals the 4. And so I end up with r equals 8 divided by negative root 3. All right, so that's enough for this video.